This video is going to be all about identities. Okay, so this is something you would typically have started in class. And in the next slide, we're going to do some examples. But the two main identities that are going to help you in grade 11 are going to be the following. The first one is to remember that sin squared of any type of angle, so we can say x, plus the cos squared of any kind of angle will always give you a value of 1. Now, this x means anything. So, I could have sin squared of 47 plus the cos squared. As long as it's also a 47, then the answer is always 1. You can try this on your calculator. So, the sin squared of a smiley face plus the cos squared of a smiley face would also equal 1. As long as these two expressions are the same, then the answer is 1. So it doesn't have to only be an x or a theta. It can be anything you like. Okay, so that's very important. They typically don't give that to you on a formula sheet. Okay, so that's one you're going to have to remember all the way till grade 12. And the next one that you should remember is that if you have the sin of theta divided by the cos of theta, well, that's going to give you a value of tan theta. Okay, that is very important. That's going to help you out quite a lot as well. Sin theta over cos theta is the same as tan theta. Okay, so let's go on to the next slide now, where we're going to do some examples. Alright, so just some clarity on what an identity is. You simply have to choose one of the sides of the expression and try turn it into the other side. Okay, so it's not an equation. So you're not, for example, with number 1, you're not going to try take this tan theta to the left. You're going to leave it alone and you're going to work on the other side. Or there's no rule about which side you should work on, but you typically want to work on the more complicated looking side and try turn it into a more simple looking. So you want to work on the more complicated one and try turn it into the more simple looking one. Okay, so let's start with number 1. So with number 1, the typical things that we can see would be, okay, so here we have a tan theta. So a good way to start this one would be to switch that into sin over cos, and then we're also going to turn this one into sin over cos. Alright, but the first thing would be just to tell your teacher which side of the equation you're working on. So we're definitely going to be working on the LHS, which means the left hand side. Okay, so now from then onwards we're going to work on the left hand side. So let's quickly go and change this tan theta, or both of them, into sin theta over cos theta. Okay, and so there you can see I haven't got the equals to tan theta written down anymore. That is because we're only working on the left hand side. I've changed the sin theta over cos theta. I've changed tan into sin theta over cos theta. Now the next thing I want to have a careful look at, and this is the areas where I often see problems, okay, with students, is something like this. Students battle how to handle that. Okay, so we're going to quickly, on a side note, we're going to just quickly work on that piece over there. Because if you can get comfortable with this, it's going to make life a lot easier for you. Okay, so what you can do is you can picture this as a fraction over a fraction. Okay, so this is the main fraction line, and so this is your top part, and this whole expression is your bottom part. But now to turn the top one into a fraction, we can just write it as 1 over 1. Okay, and then what we're going to end up with is that over there. So now we clearly have a fraction on top, so here's our main division line, of another fraction. So remember, the way to divide two fractions is to keep the top one the same, then turn the sign into a multiplication sign, and then switch the bottom fraction around. So you flip it upside down. So that's going to look like this. You're going to end up with 1 over 1 times, and now we switch that other one around, cos theta over sin theta. Okay, then you simply times top and top, which is just cos theta, times bottom and bottom, when that is just sin theta. Okay, so that whole expression that we started with over here is actually just going to become that over there. Please, if that did not make sense, just rewind the video, watch it a few times. It is so important because you're going to see this popping up very often when doing identities. So I'm now going to go do the next step in our original sum and change this 1 over sin theta over cos theta into cos theta over sin theta, because we found that it can be simplified into that. And there we can see that this expression has now been changed. Okay, so here we have this new expression over here. Now, forgetting about this second bracket, just looking at this part over here, here comes the next big thing. You got to forget about sin and cos and all of that, and what you got to see there is that you are plussing two fractions together, okay? And so an example of that would be 1 over 4 plus 3 over 7, for example. Many students that I teach, they know exactly what to do here. They tell me, oh, you need a common denominator. Well, that is exactly what we need when doing this sum over here. So your common denominator is going to be cos theta sin theta, right? And so this part is going to be multiplied with sin theta, and this part is going to be multiplied with cos theta. Okay? And so that resulting expression is going to look something like this. And so there we can see that new expression. Okay, that's after multiplying all the common denominators and all of that. And now I'm just going to simplify a little bit. So, for example, sin theta times sin theta just becomes sin squared theta, and cos theta times cos theta is cos squared theta. Another thing is that these two denominators are now the same. So you can simply add it all together over one common denominator. And so we're going to end up with sin squared theta plus cos squared theta over cos theta sin theta. Okay, so I'm just going to write that out manually. Try to keep it as neat as possible. So that's going to give us sin squared theta plus cos squared theta. And that's all over cos theta times sin theta. And then I must also just remember this. I nearly forgot that one. We must just remember this part over here that is still part of the sum. So that's 1 minus cos squared theta. Alright, I do apologize that it's getting a little bit squashed, but this often does happen with these identities. They can go on for quite some time. So let's see what we can do. So have a look at the top part over here. We've got sin squared theta plus cos squared theta. Now remember from your previous slide that that equals 1. So we can change that to a 1 over, and then I'm just going to leave the cos theta times sin theta as it is. And then what I want to do is examine this part here a little more closely. If you remember from the previous slide, we said that sin squared theta plus cos squared theta always equals 1. But remember, that is, and I didn't mention this in the previous slide, that is the starting point. You can switch that identity around however you like. So let's try get sin squared theta by itself quickly, and let's see what happens. If you had to arrange that equation to get sin squared theta by itself, you would have to take the cos squared theta over to the other side. And have a look here now. This is the same as that. And so this expression here, it tells us, is equal to sin squared theta. And so we can replace it. Now, why do we want to do that? Because the part of the whole point of identities is you want to try simplify the one side. Now, simplifying means having as less number of terms as possible. So if we can go from having 2 terms inside this bracket over here to only having 1, well, that is considered to be more simple. Okay? And so I'm going to carry on this original sum where I left off over here, But instead of writing 1 minus cos squared theta, I'm going to keep it as sin squared theta. Okay? And then we'll carry on from there. I just want to neaten up and make some space. And so let's carry on. So now we can think of this sin squared theta as sin squared theta over 1. And so we can multiply the tops and the bottoms. And so that's going to give us sin squared theta over cos theta times sin theta. Now look how this cancels. One of these sin thetas is going to cancel, so I'm just going to scratch that out, and it's going to cancel with this one. And so we're left with sin theta over cos theta. But remember, sin theta over cos theta is the same as tan theta. And that is a good thing, because look at what our answer is over here. It's tan theta. And so in the next slide, I'll show you what we should write then. So now, because we have proven it, we can say, therefore, left-hand side is equal to the right-hand side. And that would be the end of that question. Okay, and then we can go on to the next example. We can now start number 2. So our first decision will always be, should we work on the left or the right? Well, it's always better to work on the side that is more complicated and try turn it into the side that is more simple. So we'll start on the left-hand side. So we must just let the teacher know, okay, we would like to start on the left-hand side, like that. Perfect. Now let's go through each little part. So I like to see this as 4 parts. So there's this part, there's that, and there's that. Let's try and simplify can we simplify any of those parts? Well, cos x is just cos x. 1 plus sin x is just 1 plus sin x. And so if we have a quick look here, there's not much we can really do in each of the individual parts. And so now we have another look, and we realize, okay, well, we've got a fraction plussing with another fraction. And so when you are plussing 2 fractions, you need a common denominator. Now that common denominator is going to be 1 plus sin x in brackets and cos x. And so this part over here is going to be multiplied with cos x, and this part over here is going to be multiplied with 1 plus sin x. Okay, so I'm just going to write this out manually and keep it as neat as possible. So it's going to look like this: cos x times cos x over 1 plus sin x times cos x, plus, then this one is going to be multiplied with 1 plus sin x, but there already was a 1 plus sin x over there, and that's also going to be over the same denominator. There we go. So we're trying to get a common denominator, and so we multiplied this one over here with cos x, and we multiplied this one over here by 1 plus sin x, and what you do to the bottom, you do to the top. Okay, so now we can just quickly simplify that. Well, because these 2 fractions now have the same denominator, you can put them together as one term. So it would look like this. You would have a common denominator of 1 plus sin x times cos x at the bottom. And then at the top, you're going to have cos x times cos x, which is cos squared x, plus 1 plus sin x, and another 1 plus sin x. Alright, I always tell people, when doing these sums, you typically don't want to multiply your denominator, which is the bottom part. You don't want to multiply that up. You're typically going to leave that part as it is, but it is a good idea to multiply the top part out. And so in the next step, I'm just going to FOIL, or some people call it FOIL. I'm going to combine these 2 brackets together. Okay, so that's going to give us cos squared x plus, then I'm going to times the 1's together, which is 1 plus, and then there's a sin x plus another sin x. I'm just doing normal multiplying out of brackets, and then plus sin squared x. And then the bottom part is still going to be 1 plus sin x times cos x. Now remember, what does simplifying mean? Does it mean you want to have less terms or more terms? Well, it means less terms, right? So straight away, and with practice you'll start to see this really quickly, straight away we can see this and this. Now what does that give you? Remember, cos squared x plus sin squared x, or sin squared x plus cos squared x, that simply gives you 1. Okay? And so that's a good thing, because we are then going to go from having 2 terms, those 2 in purple will be 2 terms, and we're going to convert them into 1 term. And that's always a good thing. It's always good to make less terms. I'm now going to rewrite everything as, okay, so the cos squared x and the sin squared x is just going to give us 1. Then I'm going to write the other one that was already there, which is this one here. And then sin x plus sin x is just 2 sin x. Alright, and then at the bottom you just leave it as it is. Stuff will cancel, it always happens like that. Okay, then I'm going to simplify the top a little bit. 1 plus 1 is 2, and there we go, things are looking very good. Okay, now at the top we've got 2 terms. How do you go from having 2 terms to having 1 term? Now this is very important. This is going to be useful. It's going to pop up many times while doing identities. To go from having 2 terms to 1 term, you factorize. So what could we factorize at the top? Well, that's just going to be a 2. So you take out a 2 as a common factor, and then you'd be left with 1 plus sin x. And then at the bottom, we've still got 1 plus sin x times cos x. Now, look what happens. We've got a 1 plus sin x there and a 1 plus sin x there, so that cancels. And so we are simply going to be left with 2 over cos x. And if you remember from the original question, that is what we are trying to find. And so we have actually finished that question. And so we can therefore just end it in the correct way by saying, therefore, left-hand side is in fact equal to the right-hand side. We're now ready to start number 3. So the left-hand side definitely looks more complicated. So let's look at each term first and see if we can work on each term individually. So here's term number 1. Here's term number 2. So, and that's what we did in the second question. Remember, we had a look at this and we tried to simplify each term first, which we couldn't, and only after that do we try combine them. Okay, so in this second term over here we have cos theta. You can't really do anything there. Here we can change tan into what? Well, that becomes sin over cos. And so, but first we should say left hand side. I nearly forgot. Okay, so we're going to change tan into sin theta over cos theta. There we go. And then we're going to keep the original sin theta over there. And then I'll write out the plus cos theta. Okay, this part over here, you can think of this as sin theta over 1. And so we can just multiply top times top and bottom times bottom. And so that's going to give us sin squared theta over cos theta plus cos theta. Now we cannot really do anything with this term over here. It's as simple as it can be, and this term over here. But now we've got a fraction plus another fraction. Remember, this can always be thought of as cos theta over 1. So that's a fraction. And remember, when you're plussing 2 fractions, you need a common denominator. And that common denominator is cos theta. And so this term over here already has the cos theta, but this one doesn't. And so that's going to be we're going to need to multiply that with a cos theta at the top and the bottom. And so that's going to give us the original sin squared theta over cos theta plus. Now we're going to multiply this cos theta with cos theta, and we're also going to multiply the bottom with cos theta. And now many people I've seen, they often say, oh, but why don't we just cancel those? Yes, that's not wrong, but then you're back to where you were. So the whole point is we're trying to combine these 2 terms because we're eventually trying to simplify. Okay, so we're not going to cancel them out like that. The point is that now we have 2 fractions which have the same common denominator, and so we can put them together as sin squared theta. This part here is cos theta times cos theta, which is just cos squared theta. and your common denominator for both of those is cos theta. Now, at the top, we're left with sin squared theta plus cos squared theta. Now, remember, that keeps coming up, and that is always equal to 1. And so we're left with 1 over cos theta, which is, in fact, what we were trying to get to in the first place. And so we can say, therefore, left-hand side is equal to right-hand side. And now we're going to start the last question for this video. With the last one, you could sort of start on both sides. Due to the fact that the right-hand side has two individual terms, we've got this big term and we've got that term, whereas on the left we sort of just have one big fraction, so one term. I would say we should actually start on the right-hand side. I think it'll be easier. So we can start with the right-hand side this time. Although I think the left side, yeah, it would still work out. But let's start with the right-hand side. Okay. So as always, try simplify individual terms first. And if you look at cos theta over sin theta, there's not much you can do there. Tan theta, however, we know what to do with that. We switch that into sin theta over cos theta. If you do these enough times, you'll realize there's a lot of similarity in all of them. They become very repetitive. Now, forget about that we've got causes and sins. What we actually have is two fractions that are minusing from each other or subtracting from each other. And so we simply need a common denominator. That common denominator is going to be sin theta times cos theta. And so this one has to be multiplied with cos theta, and this one has to be multiplied with sin theta. But then what you do to the bottom, you also do to the top. And so that's going to eventually look like this. It's going to be cos theta times by cos theta over sin theta cos theta. Minus, this one's going to be minus sin theta times by sin theta over sin theta and cos theta. Now the two denominators are the same, and so we can combine these two fractions with one denominator, and that one denominator is going to be sin theta times cos theta, and then cos times cos is cos squared theta, sin times sin is sin squared theta. Now don't be tempted to turn this into a 1. It's not 1. The identity only works if there is a plus in between. And so it's a bit tricky what we should actually do next. So let's have a glance over at what we want our final answer to be. So we've got this part in our denominator. There it is. But the top part doesn't have any cos. So we need to get rid of this cos somehow. Okay, so this comes with a bit of practice, but remember we said that there's this identity that goes sin squared theta plus cos squared theta equals to 1. We also said that these identities can be rearranged. So let's rearrange it for cos squared theta. And what you're going to end up with is 1 minus sin squared theta. What we can then do is replace this cos squared theta with that, because we've just shown over here that cos squared theta is equal to 1 minus sin squared theta. And so we can replace it. A good habit is to always, when you replace something, replace it in a bracket. So it's going to become 1 minus sin squared theta minus sin squared theta over sin theta times cos theta. Okay, so the brackets aren't really useful in this scenario because there's nothing in the front here. But if there was a minus, for example, that minus would then jump in and change all of the signs. And so the bracket's not really useful for this one, but it's a good habit. A bracket will never make it wrong. Okay, so I'm just going to rewrite that. And then if we simplify that, you're going to end up with 1 minus, and then there's minus sin squared theta minus another sin squared theta is minus 2 sin squared theta over sin theta times cos theta. And that, I believe, is what the final answer is supposed to look like. And so we can then say, therefore, left-hand side is equal to right-hand side. And that is the end of this video. Thank you for watching.